Yes. Most definitely. I've got a lot of people. So you guys are going to run the whole thing for me today. Mikey won't be there, though. My sister's in town, so it's okay. He'll be there the rest of them. Just not this week. All right. We got the essential question written? We're going to figure out how to find the average value of the function here in a few minutes. That's the one that is the big important one for this. Okay. So before we do that, we're going to talk about the mean value theorem for integrals. There's two things in here today that are kind of nice to knows. This one is not likely to pop up on the AP test. The mean value theorem for derivatives absolutely will pop up on the AP test, but I don't want to send you off to a college class and you not have seen something, okay? In fact, just yesterday I was checking my email from over break, and one of our graduates from last year who was in BC with me said, thank God I took calculus. He was on, wherever he's at school, he's on quarters. And he said he felt really bad because it moved so fast. And he took BC here, but he retook AB in college. He said, thank God he took it because it went so fast that the kids who didn't take it just died. So, and he did not pass the AP test either time. So it's really good. So you're doing good things for yourself right now, okay? Doesn't mean you won't pass the AP test, but, you know, you're doing good things for yourself right now. All right, so mean value theorem for integrals. F is continuous on a closed interval, then there exists a number C on the closed interval such that. So basically it's a formula, okay? It's saying that the integral equals that formula. So the function evaluated at whatever C is, and then B minus A, which is your interval, okay, times B minus A. Basically what that does, what they're trying to do is we're still trying to get close to that concept of if we have to estimate this, okay, how would I take this gap, or take this here and fill it into that gap there, okay? So the mean value is one of those ways to do it. Average value is also a way to do that, okay? And it tends to show up as average value here in a few minutes on the AP test. But we're going to talk about one or two of these, okay? So let's talk about this one. So they want us to find the C value, okay? So there's two things we're going to do. First of all, we're going to integrate it on this interval. And then we're going to take that number and set it equal to this little formula that they gave us, okay? So I'm going to start by integrating, which we know how to do, a definite integral from 1 to 4 of 3x squared minus 2x dx. So it makes the problem seem long. It's more of a tedious thing than a long thing, okay? All right, so what do I get when I integrate 3x squared? Cubed over 3 minus 2x squared over 2, and then we go from 1 to 4. When we have the numbers there, we don't do plus c. Before I do that, I'm going to simplify it, right? And probably if this was actually a test, I probably would be pretty sloppy about my work and not rewrite that line because that's taking me time. Okay? Because I can probably plug in with, even though those are crossed out. All right, let's start putting the 4 in. What's 4 cubed? 64 minus, what's 4 squared? 16. And then remember, you do a minus and a parentheses. Okay, what is 1 cubed? 1. 1 squared? 1. Good. What happens to this back piece? It zeroes out. It's canceled. All right, so 64 minus 16 is what? 48. So that is just the integral. Remember, I'm doing this little formula that they gave me, which was the integral, whatever the integral is, equals f of c times b minus a, okay? So I've got to take my number for whatever my integral is and set it equal to this mess here, okay? So I'm going to set 48 equal to, I'm going to leave it at, so f of c says take c and plug it into my function. So my function is 3, and instead of x's, I'm going to put c's in there. And then b minus a is these two numbers here. So what's my b number? 4, right? It's always the bigger part of the interval. So 4 minus 1. Shouldn't come out, well, I guess it could come out negative, but you know, it should be in numerical order, okay? The bigger number ends up going first. All right, so you got 48 equals, let's see, what's 4 minus 1? 3. Okay, there's 2 ways you can do this from here, okay? You can distribute, all right? Or couldn't we divide that over to the other side? If I divide it to the other side, my numbers become smaller, and if I'm not using a calculator, it's better for my numbers to become smaller, isn't it? So rather than trying to make them bigger and harder to work with, I know that that's divisible by 3. Okay, so we're going to go ahead and put that in there. So how many times does 3 go into 48? 16. So I've got 3c squared minus 2c. I probably could have, oh no, I can't do factor yet. I got to move this guy to the other side to factor it. Okay, remember good old factoring? All right, so how do I move the 16 to the other side? Subtract it. So 3c squared minus 2c minus 16. All right, take a minute on your paper on your own. Everybody factor it. If you were in my class, you're going to have to use a magic X and probably a box. Okay? I don't know how Rondeau taught it, so you need to do whatever you do for a leading coefficient. Okay? Everybody starts with the X, though. I know that. Magic X and box for us. How we doing? Still doing it. All right. What do we get in the magic X?
A negative 8 and 6.
Okay, 8 and 6, and it's negative. Okay. I know there's a couple of other methods. So this is what I do with the box, okay? Because how often do we get a leading coefficient on one of these? Not very often, okay? So it likely is probably, I can't say that for sure, but if there's a chance on the AP test you won't get a leading coefficient. But we do need to be prepared just in case. All right, so I need 2 numbers that multiply to 3. What are they? 3 and 1. 3 isn't going to divide the 8. It will divide the 6. So I'm going to put my 3 on the top, and then my c there. How many times does c divide negative 8c? Negative 8. How many times does 3c divide 6c? 2. 2 times negative 8 is? Negative 16. So I end up with 3c minus 8 and c plus 2. And if you got it a different way, that's okay. All right? All right. So I'm going to take both of those and I'm going to use my good old zero product property. Remember that? Set them equal to 0. So we've got 3c equals 8, c equals 8/3, and c equals what? Look at your interval. Can I use both of those? Oh, which one can't I use? The negative 2 is extraneous, right? It's outside our interval. Had my interval been from, like, you know, negative 3 to 4, I could use the negative 2, but I can't in this case. Okay? All right. It wasn't like any step was hard. It was just long and tedious, right? So let's practice it one more time. There is only 1 on the homework, okay? Because it isn't super important. So this is, like I said, it's a nice to know thing. It's not a We've got to stress out about knowing this thing. All right, so the first step was integrating, right? So I'm going to rewrite that into an integral, and I'm going to rearrange it a little bit. I'm going to start by putting, remember how we put the number in front of the integral? We're allowed to do that. Okay, because that sometimes just kind of makes it neater, puts it out front. At the same time, I'm also going to bring this upstairs by doing what to the exponent? Making it negative. Good. All right, so I've got, we're going to go ahead and integrate that. So I've got 4x. Remember, we have to do what to the exponent? Add 1, what do you get? Negative 1. We divide by the new exponent, so we're dividing by negative 1, which is just going to make the whole thing negative, right? And I forgot to put my limits on there, didn't I? So I am going to go one step to clean it up. I don't like having a negative exponent when I have to plug in numbers, so I'm going to bring that back downstairs. The 1 gets to go away when I bring it downstairs. All right, now we're ready to plug in. At least they're nice numbers, right? So I plug in the 4. I've got negative 4 over 4 minus negative 4 over 2. What's going to happen to the double negative? Positive. So let's see, don't I have negative 1 plus 2? What's that equal to? 1. That's the first half of the problem. So remember the idea between this mean value theorem for integrals is we take the integral, whatever we get for the integral, and we set it equal to f of c times b minus a. So the number I'm plugging in for my integral is 1. This says put c into the function the way it looks, right? So 4 over c squared. This says what numbers do I need to plug in there? 4 minus 2. Perfect. Okay. Let's see. What is 4 minus 2? 2. So I've got 4 over c squared times 2. What's 4 times 2? 8. Could I divide that over? Sure, but that's going to give me a fraction, right? So in this case, it's better to probably leave the 8. Oh, I don't know why I turned my squared into a cubed. Don't do that. It's squared. All right, I'm going to get this to the other side by multiplying it over. So what's 1 times c squared? C squared. All right, and then what do I need to do with that c squared? Square root. Technically, when I take a square root, I'm supposed to do what? Plus or minus, but look at your interval. Do I need the minus? No, I only need the plus. Square root of 8 is a perfectly good answer. If you go through the simplification process, you'd end up with 2 square root of 2. Okay, so both of those are perfectly good answers. Once you get to this spot on the AP test, I would stop. I would not go to 2 square root of 2. Okay, unless it was multiple choice. All right. Okay, so that was a nice to know thing. Here's the thing you have to know. Okay, so go ahead and write that formula down. You're going to have to memorize this formula. I believe, because this is really, really short, the test is like next Friday. So, yeah, I know, it's quick, right? Quick. So you'll want to make sure you get this down before the test. Okay, and I guarantee this is on the AP test. It'll probably be on a free response question. Okay, also embedded in the multiple choice, but usually we see it in a free response. It goes really, really well with the Riemann sum table question. It typically is in there. In fact, they usually make you do the Riemann sum and the average value out front. Okay, so there's 2 different things that when we have average, you got to be careful, okay? First semester, one of the first things we learned was average rate of change. That's different than average value. Average rate of change means you do a derivative, okay? Average rate of change is the slope of something, okay? The average value of something, it's basically the same thing as kind of the mean value theorem. It's what basically kind of makes this so it averages out and becomes the rectangle versus the curves. How do I take this and fill it in there and this and fill it in there, right? It averages it out. So all we do, the only big difference between taking a regular integral, definite integral, and that is we do 1 over b minus a out front. And that gives us what we call the average value, okay? So there's one additional little step. All right, so let's try the average value on a couple of these. So we're going to do 1 over b minus a. So remember, b is always your second number, so 3 minus 0. And then we're going to integrate from 0 to 3. of x minus 3x, and I'm going to rewrite it as the 1/2 power dx. And technically, they wouldn't mark you down for this, but technically there should be parentheses around that. If you left off a dx on the AP test on the period, they wouldn't mark off for that, typically. All right, so this obviously is going to become what out front? 1/3, perfect. Okay. When I integrate x, what do we get? X squared over 2 minus 3. Notice I left space. X, when I add 1, I'm really adding 2 over 2. So what power? 3 over 2 divided by 3 over 2 or multiplied by 2/3. I planned for that flip, right? I knew there was going to be a coefficient come in. And then we're still integrating from 0 to 3. All right, what happens with these 3's? They cancel. Good. All right, so I'm not going to rewrite a clean line. I'm just going to start plugging in. Okay, so I've got this 1/3 hanging out in front. What's 3 squared? 9 divided by 2 minus 2 times 3 to the 3/2 power. What happens when I put 0 into both of those terms? 0. That looks like a really good candidate to put in your calculator at this point. On the AP test, if this was a free response non-calculator, you stop, you have the answer. Don't calculate it. You've got a numerical answer right there. Okay? But let's go ahead and get the decimal point for me. Okay? And let you do it. It looks like I have the wrong answer last year. Be interesting to see what you guys get. All right, anybody got a number for me? That's what we wrote down last year after like 3 other choices. So last year, I'm looking at my notes and I don't have this divided by 2. I don't know why. It should be. So did everybody get the negative 1.964?
Yeah.
You got a dimension error? Oh, don't put the bracket, put parentheses in your calculator. You know, okay, so here's why. Let me explain the dimension error. There's another, remember when we did Kramer's rule and we did determinants? Okay, there's another branch of algebra called matrices. Okay? And if you guys can take a linear algebra class in college, it's awesome. Okay? It's a lot of fun to do matrices. We just don't have time in our curriculum to teach it to you guys. But that's what the brackets are for in your calculator for matrices. Okay? That's why they say dimension error, because you use dimensions in matrices. Okay? So use parentheses in your calculator. That was my fault for writing brackets, probably. All right, let's try one more average value. Okay, and then we'll try the second fundamental theorem here. Okay, so there's a typo in here. There should have been a squared on here. Let's put a squared on it. Okay, is there a squared in your notes? No, okay, I put a squared on it. We're going to fix that for next year here. Add a squared in there. Okay, so let's look at, so average value, I have to do 1 over what out front? 5 minus 2, good. And then I put my limits on, 2 to 5. I am going to, let's see, I'm going to rewrite this. I've got 9, and I'm going to bring this upstairs. How do I bring it upstairs? X to the negative 2 dx. Okay, what do I get for my fraction out front? It's not always going to be 1/3. It happens to be what we had. Okay, I'll use the parentheses so I don't confuse you this time. All right, so we've got not negative 9 yet. 9 x. I have to add 1. What do I get? Negative 1. Divide by the negative 1, which is going to make it negative 9. And then I'm going from 2 to 5, right? All right, I'm going to spend a line cleaning that up before I plug in. Ooh, could I cancel here a little bit? Yeah, why not? 3 goes into negative 9. Negative 3 times. We might as well get rid of that and not have to write it again. Alright, so we've got negative 3. And then this is going to end up going downstairs, isn't it? Over x from 2 to 5. Okay. So we've got negative 3 over 5 minus negative 3 over 2. What's going to happen with the double negative? Positive. And we're going to have to get that in tenths, aren't we? Yeah, no choice on that one. So this one is negative 6 tenths. And this one is 15 tenths. So how many tenths do we end up with? 9 tenths. Oh, don't box your answer, right? I was reading through another list again yesterday, and I found that tip again. Don't box your answer. It's apparently because the readers have to read the boxed answer, but if you have something else correct somewhere else, they can read any answer. So, don't box it. Alright, so there's one other little thing we're going to talk about today, and this is kind of a hit or miss thing. It's kind of weird. It's called the second fundamental theorem of calculus. Do we have that little definite integrals diagram there? Okay. It's at the top? Alright. So, basically, sometimes it's a possibility that they give you a function up here. Okay? When they give you a function up here, what you have to be careful of is, what they like to do with this is they like to say, take the derivative of that. Okay? And remember when we take derivatives and integrals basically cancel each other out. That's the nice thing about them. But when you take the derivative of it, not only do you have to plug that x in, but you also have to watch out for the chain rule. All the ones in the book don't use the chain rule piece of it. So I tend to teach this kind of minimally here, and then I'll teach it better when we start seeing some AP problems. Okay? So it wants us to evaluate this function. So basically what I'm going to do is I'm going to integrate it the way I always would, okay, and plug those values in. Okay, because it could be a function I'm plugging in, or it could be a number I'm plugging in. It's still a definite integral. Rules really haven't changed. Okay? So, what is the integral of cosine of t? Sine t, and I'd evaluate from 0 to x. So I'm going to say sine of x minus sine of 0. What's sine of 0? 0. So it's just sine of x. That wasn't so bad, right? Oh, don't box your answer. Apparently over break I totally forgot that, huh? My bad habit's been there a lot longer than yours has. Alright. So, I don't know why we have that there. Oh, the purpose of that x thing, okay, is then if I do this process here, couldn't I plug in any value for x and I don't have to keep integrating it multiple times? I could just plug in any value. So now that I have it integrated, I could plug in pi over 6 and figure it out. I could plug in pi over 4 to my answer and figure it out, right? It makes a nice little generic formula for us. Okay, so that's the purpose of it. Now we get to the second fundamental theorem. I think you have to write that down, right? Okay. So write that down. All right. We got it? Yeah. Okay. So, the big takeaway for the second fundamental theorem is that a derivative in an integral, when I integrate it, I get the function back with the x plugged in. Okay? Typically, this is a 0 down here for the a value. Okay? So, f of 0 is likely going to go away. Okay? Probably what I would do with it is I would just integrate it the way it looks, okay, and not try to take too many shortcuts with it. So let's see what we can do with it, okay? So we're supposed to integrate the function as a function of x and then demonstrate the fundamental theorem of calculus by differentiating the result. Okay, So let's do part A. They gave us the function there, so I'm going to go ahead and I'm going to integrate it just the way it looks, just like I did on the last example. Okay, so when I integrate t, what do I get? T squared over 2. And then when I integrate -3, what do I get? -3t from 0 to x. Okay? I'm keeping the notation of the f of x equals because that's the way they did it. I'm going to go ahead and plug in my x and plug in my 0. So I'd have x squared over 2 minus 3x. If I put in my 0, what's going to happen to both of those terms? They're going to cancel. They're going to 0 out, right? So that would be my answer. What they want me to do now in part B is they want me to take the derivative of it and check to make sure I get back to the original, okay? So obviously with x's in it instead of t's, right? So let's check it. So if I take the derivative of this thing, where's the 2 going to go? In front. So equals 2x over 2 minus what's the derivative of -3x? 3. And then what happens with these guys here? Cancel. On the AP test, they'll never have you check anything. Okay, that's just up to you. So did we get what we started with? Yeah, except that there was a t in it, right? So we got it to check out. All right, let's try this one. Okay. So this one I think the instructions changed, right? This one said integrate and then demonstrate with the derivative. Okay, this says just use the fundamental theorem. So on this one, what I'm going to do, remember the fundamental theorem says I'm going to take the derivative of the integral. Okay? So this, because they want me to find, the instructions say find f prime. So I'm going to take the derivative of that side, and I'm going to use this notation to take the derivative of this side. Okay? I'll show you, I'm going to go back to the theorem here in just a second. So just write that down and I'll go back and we're going to look at it. Okay, addition and subtraction are opposites of each other, right? So they basically cancel each other out, right? Same thing with multiplication and division. Same thing with derivatives and integrals, right? They're opposites of each other. They're opposite operations, okay? So don't opposite operations cancel each other out? That's what this theorem is saying, that this and this cancel each other out, and I just get the function. That's whatever function, but what got plugged into the function? X. Okay, so that's where we're going to get it to with it today. Okay, so we see this. We know that these guys are going to cancel each other out, and what do I have to plug into the function? X. So we're going to have the square root of x squared plus 1 dt. I'm sorry, not dt. Done. We integrated it, right? So the dt or dx part goes away. Yes.
If they cancel, then why are they even there? They just say to plug in the x.
Because of the instructions, the way it's formatted, right? That's why they're there. Okay? That's why, again, it's probably not even gonna say use the second fundamental theorem. It'll probably just show a function like this and say take the derivative of it. Okay? Alright. Let's look at this one. Let me see if I can let's see if we can do this one. Okay? So I'm gonna do this one kind of the old school way. I'm not gonna try to so I'm gonna show you another way to do this because I don't have a 0 on the bottom. Do you see how there's a function on the top and the bottom? So I'm gonna take a different approach with this one. Okay, I'm gonna integrate the way we always would have, and then I'm gonna, because I still have to find a derivative, after I plug in, I'm gonna find the derivative. Okay, so let's integrate it. So when we integrate 6t, what do we get? Good, plus, when I integrate the 1, what do we get? T, from x to x plus 1. Alright, I'm going to simplify before I try to plug in. So 2 goes into 6 how many times? 3. So I've got 3t squared plus t from x to x plus 1. Alright, it's going to get ugly for a minute. Alright, so I'm going to plug my x plus 1 in. So I've got 3 times x plus 1 squared plus x plus 1 minus, put parentheses, 3. Now I'm plugging in x into the function, x squared plus x. Alright, what am I going to have to do with this guy right here? I'm going to have to do some foiling, right? X plus 1 times x plus 1. So we've got 3. What's x times x? X squared. What are you going to get in the middle? 2x, and then at the end? 1. Good. And then, let's see. I've got a plus x plus 1. I'm going to distribute that in while I'm at it. Negative 3x squared minus x. Looks like before I go for another line here, I could do some canceling, couldn't I? Don't my x's go away? Doesn't this and this go away? All right, and then I'm going to go ahead and distribute that 3 in. So we've got 3x squared plus 6x plus 3 plus 1 minus 3x squared. Make sure I did it right. Yeah. I need more space? Okay. Sorry. I'm going to write more space down there. Yeah, it looks like I definitely need more space. Okay, we've got maybe 2 lines. Okay? All right, so what happens with the 3x squared and the 3x squared? Cancel. Perfect. Okay, so really, and remember, this is the function, right? The function equals 6x, what's 3 plus 1? 4. Have I taken its derivative? No, but I could take its derivative. That should be pretty easy, right? What's the derivative of that thing? 6. Done. Different approach. So when you see something that's other than a 0 here, I would probably take this approach, okay? If you see a 0, cancel the derivative in the integral, okay, and plug an x in there, okay? All right, the assignment is posted in Haiku. All right, so you've got plenty to work on there. If you did your homework and you really want stamps, we can do that. Oh, I know what we want to do. Okay, everybody flip to where the homework is in your notebooks. Okay? So I'm going to hit stop on this thing.